Hi, in this lesson, we're going to go over Project Euler problem 21 and build a solution for it. This is one of the more complex problems that we're going to go through, and when I read what we need to do, I think you'll see why. So what are amicable numbers? They give a few different explanations. First, they give a definition here and then an example. We'll go right into the example. So the proper divisors of 220 are 1 through 110. So all that means is that each one of these numbers can be evenly divided into 220. And so what we're looking for is to see this number, this D, 220 equals 284. Now, the proper divisors of 284 are 1 through 142. So D, which is divisors, 284 equals 220. So let's read a little bit more on the definition. So just to use some algebra, if dA equals B and dB equals A, where A is not equal to B, then A and B are amicable pair, and each of A and B are called amicable numbers. So there's not a ton of these, but when they run into each other, then you'll see they have a lot of the same different or same values at the end. So what we want to do is evaluate the sum of all the amicable numbers under 10,000. So we're going to have to do quite a bit here, but I'll take it nice and slow, and hopefully it'll make sense when we're done. So first thing we're going to do is require the math and library. From here, we're going to do some metaprogramming and open up the integer class. And in here, I'm going to create a new method called dsum. And inside of dsum, I'm first going to just simply return 1 if the value is less than 2. And that's just common sense. So, if you have, if you try to call this on 1, then you're not going to have any other divisors besides itself. So that's something just to bypass any of the values that'd be 1. And now we're going to create a variable called PD and call prime division on it. So I'm going to say prime underscore division. And then we're going to call a method called flat map. And in this method, we're going to pass it a block with 2 iterator variables, one being n and the other being p. And here we're going to this is where the flat map method comes into play. We're going to pass the iterator variable n inside of that array element, and then, or the array selector, and then multiply that by p. And so right here, all this is just in case that sounds complicated, it actually is. But all it's going to do is it's going to give us all of the prime divisors. So now that we have that, now we need to get all the possible prime divisor combinations. And thankfully, we have some nice methods in Ruby that make this possible. So I'm going to first call that I'm going to add 1 into the array, and then I'm going to add this into our combination block. So in here, I'm going to say 1 to PD, which is our prime divisor, right, that we just called up there, we created up there. And I'm going to call the size on that. So it's going to go from 1 all the way up until the end of that array. And then from there, I'm going to call flat map again on it and pass into the block an iterator variable of e. And here we're going to call our prime divisors again, and we're going to get all the different combinations of them. So I'm going to find all the combinations of e, and then I'm going to map that and pass in a block here. In this block, I'm going to pass iterator variable f and say f dot reduce. And for reduce, it's a method pretty similar to inject. There's some key differences, but we won't go over those now. And here I'm going to pass a method into reduce, and I'm going to pass a multiplication method. And so I'm going to have, let's see, make sure I have my curly braces ended. Okay, yes. And now I want to get the unique values, and then I'm going to pass inject to grab the sum. Okay, so what does this do? This is super complicated. It's probably one of the more complex method chaining that we've done in this course. So anytime you add one value from an array, you can always add array elements together. So you can test all this out in the IRB console, just so you know I'm not making anything up. So say 1 plus, we can even pass 5. And you can see that just adds a one element in there. So that's all we're doing on here. Now this this value right here, we're just getting the set of prime divisors, which we set up here in this variable. We're going to the very end of it. And then we're calling the flat map method again, and we're passing it a nested block. We're passing the combination one, which is going to find all the different combinations that are in our prime divisors, and then it's going to map this multiplication method. And then at the very end, we're grabbing unique, and then because you only want to grab the single ones that match, and then inject passing in plus is going to return the sum of all those values. And that's all we need to do on with the dsum method. And now we can actually use it. I'm going to create a method that says find dsum and pass in one argument, which is just going to be n. And now we want to say n times inject. And so what this is going to do is just go find the dsum for any value of n. And so we could have hard-coded that in, but we will not. So I'm going to pass two iterator variables here. And in the first one, I'm going to say, I'm going to create a variable called other. And I'm going to say cur.dsum. And here I'm going to have our last line of code and say cur is not equal to other and other dsum. So this is where I'm calling the dsum method up here at the top, and we're calling this to see if this is equal to cur, and this is a ternary operator, so I'm simply going, depending on what the value of that is, I'm going to either return the sum plus cur or just the sum. Okay, that was a lot of code. Let's see if this actually works. So find dsum, pass it in 10,000. Let's see, Ruby, Project Euler 21, and 31,626. That is the correct answer. You can plug it in here, and that will return. That is the sum of all the amicable numbers under 10,000. So great job. That one was definitely way more complicated, so I'd play around with this, change up some of the values, change up some of the variables, definitely explore some of the methods that we haven't talked about before, like flat map, and all of it's in the Ruby documentation. But this is a pretty complex method, but I think if you read the full description on what we had to do, it's a great implementation for being able to find all those values. And really, in all honesty, being able to do it in just 20 lines of code is pretty impressive. So great job, and I'll see you in the next video.